Welcome guys, today we'll look at how to carry out a certain non-parametric test. One refers to as the Spearman Rank Correlation Coefficient. Data here discuss of 10 students on a mathematics examination and a biology examination. Find the coefficient of rank correlation. Now this is the formula used in finding the coefficient of rank correlation. 1 minus 6 summation d square over n raised to power 3 minus n. Now we are expected to rank each of the variables, that is the x and the y variables. Here we go. Let's rank the first variable x by assigning 1 to the least value. Looking at our data here, the least value on the x variable is 45, so we assign rank 1 to 45, followed by 53, which takes the rank of 2. 57 takes the rank value of 3, 59 takes the rank value of 4, 63 takes rank 5, 71 takes the rank value of 6, 72 takes the rank value of 7, 78 takes the rank value of 8, 86 takes 9, lastly 98 takes the rank value of 10. Now let's proceed to ranking variable y, that is the biology examination score. We represent that with RY. The least value here being 37 takes the rank value of 1, followed by 41, which takes the rank value of 2, 56 takes the rank value of 3, 59 takes 4, 70 takes 5, while 77 takes 6, 83 takes the rank value of 7, 84 takes 8, 85 takes 9, while 87 takes the rank value of 10. Now let's proceed to finding the difference in rank. D. 3 minus 7 minus 4, 1 minus 1, 7 minus 2, 8 minus 8, 2 minus 3, 5 minus 9, 9 minus 6, 10 minus 10, 4 minus 5, lastly 6 minus 4, 2. Let's proceed to fill in the d square column. D square simply entails the square of each of the d values. Minus 4 square, 16, 0 square, 5 square, 0 square, minus 1 square, minus 4 square, 3 square, 0 square, minus 1 square, lastly 2 square, 4. Now let's sum up the d square values. 16 plus 0 plus 25 plus 0 plus 1 plus 16 plus 9 plus 0 plus 1 plus 4 gives 72. Going back to our formula, we could see n. N simply means the sample size. Remember the question said we have 10 students. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore, our n value is 10. Now to find the rank correlation coefficient, we will fix each of these values into our formula. So we have 1 minus 6. Summation d square value will go 72. Then divide by, we have n cubed here. N value is 10. That is 10 cubed minus n. So we have 1 minus 6 multiplied by 72. 432 divide by 10 raised to power 3 is 1000. 1000 minus 10, 990. So we have 1 minus 423 divided by 990. Therefore, 1 minus 0.436 gives 0.564. Now, we'll find the critical value of the Spearman Rank Correlation by visiting our Spearman Rank Correlation table at alpha is 0.05 and our n value is 10. This is Spearman Rank Correlation table. We're given alpha at 0.05 and our n value is 10. So we trace this to 0.05. The value is 0.648. Since it is greater than the calculated value, that is 0.564, therefore we do not reject null and conclude that there is no significant correlation between the scores of students on mathematics aptitude examination and biology examination. Before we proceed to calculating the rank correlation coefficient for tied data, if you are getting value from this video and yet to subscribe to my channel, please kindly subscribe. Thank you. Rank correlation coefficient is calculated with any of these formulas. However, if there are tied data like we have on our table, that is where a particular value appeared more than once. On our x variable, we could see 7.2 appearing twice, so also 7.4, and so on and so forth. On the part of the y variable, we could also observe tied data, that is a particular value appearing more than once. In a situation like this, we employ the correction for towels formula. This entails that where the given data are tied, the most suitable formula to calculate the rank correlation coefficient is this. Now let's rank the x and y variable data. The least value here is 7.1, takes the rank value of 1. Next is 7.2. We could observe that 7.2 appeared twice. So the 7.2 here takes the rank value of 2, while this takes the rank value of 3. So 2 plus 3 gives 5, and then we take the average of 5. That is by dividing by 2, which is equal to 2.5. The 7.2 here has the rank value of 2.5, so also the one here. Next is 7.4, but we could see that 7.4 appeared in 3 places. So this 7.4 is expected to take the rank value of 4, while this takes the rank value of 5. Lastly, this takes the rank value of 6. Therefore, 4 plus 5 plus 6 gives 15. Dividing 15 by 3, being the number of times 7.4 appeared, equal 5. So we have rank value of 5 here, so also here and here. The next value is 7.6. 7.6 is expected to take the rank value of 7, while 7.7 take the rank value of 8. Next is 7.8, which appeared twice. 7.8 here is expected to take the rank value of 9, while this takes the rank value of 10. 9 plus 10 gives 19. 19 divided by 2, 9.5. And 7.9 takes the rank value of 11. Lastly, 8.3 takes the rank value of 12. Now let's proceed to ranking the y variables. The least value here is 10.2 and it appeared 12. This 10.2 is expected to take the rank value of 1, while this takes the rank value of 2. So 1 plus 2 gives 3. 3 divided by 2, 1.5. Next is 10.3, which takes the rank value of 3. 10.4 takes the rank value of 4. 10.5 takes the rank value of 5, followed by 10.6, which takes the rank value of 6. 10.7 takes the rank value of 7. 10.8 here is expected to take the rank value of 8. We also have another 10.8, which is expected to take the rank value of 9. So 8 plus 9 gives 17. 17 divided by 2, 8.5. 11.1 takes the rank value of 10. 11.2 takes the rank value of 11. Lastly, 11.4 takes the rank value of 12. Now let's find the difference in rank. 5 minus 4, 7 minus 8.5, 11 minus 10, 2.5 minus 1.5, 5 minus 3, 1 minus 1.5, 5 minus 7, 2.5 minus 5, 9.5 minus 8.5, 8 minus 11, 9.5 minus 6, lastly 12 minus 12, 0. Now let's fill up the d-square column by taking the square of each of these values. 1 square, 1, minus 1.5 square, 1 square, 1 square again, 2 square, minus 0.5 square, minus 2 square, minus 2.5 square, 1 square, minus 3 square, 3.5 square, lastly 0 square. Now let's get the summation of this square. Plus 2.25 plus 1 plus 1 plus 4 plus 0.25 plus 4 plus 6.25 plus 1 plus 9 plus 12.25 plus 0 gives 42.0. There are two measurements at tied at 7.2, 3 at 7.4. and 2 at 7.8. Therefore, summation of the number of tied values of S in a group of tiles will be equal summation t raised to power 3 minus t over 12. Since there are two measurements tied at 7.2, t becomes 2 raised to power 3 minus t plus there are three measurements tied at 7.4. So the t there becomes 3 raised to power 3 minus t. 3. Also, there are two measurements stored at 7.8. So our t here becomes 2 raised to power 3 minus t, 2. And then divide by 12. 2 raised to power 3 is 8. 8 minus 2. 3 raised to power 3 is 27. 27 minus 3 plus 2 raised to power 3. 8 minus 2 divided by 12. 6 plus 24 plus 6. 36 divided by 12 gives 3. Therefore, the number of tied values in a group of X is equal to 3. Let's also find the number of tied values in a group of Y. There are two measurements tied at 10.2. Therefore, our t value is 2 raised to power 3 minus 2. Also, there are two measurements tied at 10.8. So our t value is 2 raised to power 3 minus t being 2 divided by 12. 2 raised to power 3 is 8. 8 minus 2, 6 plus 2 raised to power 3, 8 minus 2, and then divide by 12. 6 plus 6 gives 12. 12 divided by 12 equal 1. Therefore, the number of tiled wires in a group of tiles is 1. Now, let's find the value of n being the sample size. And we could get that by count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Therefore, our n value is 12. Calculate the rank correlation coefficient by employing the correction for ranks formula. This correction for rank formula, we have n raised to power 3. Our n value is 12 raised to power 3 minus n. With this, our n value is 12. Divide by 6 minus summation d square value is 42.0 minus summation tx, which we got 3, minus summation ty, we got 1, over the square root of, we have n raised to power 3, n value is 12, raised to power 3 minus n, 12, and then close bracket, divide by 6 minus 2, and then multiply by n raised to power 3, our n value is 12, then raised to power 3 minus n, close bracket, then divide by 6 minus 2, multiply by summation ty, our ty value is 1. 12 raised to power 3, which is equal to 1728 minus 12, divide by 6, minus 42 minus 3 gives minus 45. Minus 45 minus 1 minus 46, and then divide by square root of 12 raised to power 3 minus 12, divide by 6, minus 2 multiplied by 3 minus 6, 12 raised to power 3 minus 12, then divide by 6, minus 2 multiplied by 1 minus 2, 1728 minus 12, and then divide by 6 gives 2x6 minus 46 gives 240. Divide by the square root of 1728 minus 12, 1716 divided by 6, 280, and then multiply by 1728 minus 12 divided by 6 gives 2x6. 2x6 minus 2, 284. So we have 240. 280 multiplied by 284, 240 divided by the square root of 79520, which is approximately 282. 240 divided by 282 gives 0.851. Therefore, the rank correlation value employing the correction for tiles is 0.851. Now, let's proceed to testing the hypothesis by visiting the Spearman Rank Correlation Coefficient table at alpha at 0.05 and our sample size n equal 12. This alpha at 0.05, that is the level of significance, and our n value is 12. Then we trace this down to 0.05, 0.587. Since the calculated value being 0.851 is greater than the tabulated value, that is 0.587. Therefore, we reject null and conclude that there is significant relationship between x and y variables. I hope this video is clear enough. Please, if you really got value and at this point you are yet to subscribe to my channel, please kindly subscribe. Also, do well to share this video with anyone who might find it useful. Comment with any questions or topics you will want us to cover in future videos. Give this video a thumbs up. Thanks so much for watching. See you in the next video. Bye.